My name is Randy, and this is my commentary on vector source code. I've been looking at the code for the face and eyes. We've done a shakeout looking at the base infrastructure for sending display frames to the LCD and loading the animation file and setting up the data structures for interpolation. The next four files are the most interesting ones. They coordinate when to add in blinks, distorting the eyes and glancing around to give them a more organic and lifelike feel. Is the code to draw or render the eyes to a frame buffer, and then code to distort that frame buffer by adding in scan lines to give it a retro technology feel. Where we begin looking next is the track layer component. This is kind of a base class that will be used for each of the animation tracks, one for the audio, another for the backpack lights, and then one for the face. What we really want to look into is the face one here, but overall let's just kind of take a scan of the header file and then this class. So it's got the usual helpful comment block at the top, some header file boilerplate, and then which types and animation structures it should incorporate. It's got the usual namespace stuff, but notice that they've added a third level here where it indicates an anim module, and then they do some forward declarations, some classes that'll be useful. Again, the one that we're going to really dig into here in a little bit is the faceLayerManager. Right now, this trackLayer component is where we're looking. They have a structure here, which is going to probably, it says it's going to be an output of some sort of one of the methods below that indicate whether or not it has each of these three tracks for each. And it looks like it's going to be an individual frame that gets keyframe that gets generated at any given time step, I suspect. So then just some usual things to construct and destruct the class or the instance. Something to initialize it, probably with the this animation streamer is probably a overarching flat buffer or other helper to read in the animation file and then coordinate interpreting that into local fields. Update is probably getting the next keyframe from the file. I don't know what enable procedure audio exactly means, but it has a false enable, so they're probably something related to generating sound effects, but related, making gear noises or grunting or breathing, if they whatever they might have thought of as and we're exploring, that might be created by this animation engine as well. So this next method here, let's see here, pulls the current keyframe from the various tracks. So we have the timestamp that we're looking for, and then it's going to get the keyframes that are start at that timestamp. They don't say what store face is here, but that'd be interesting to find out later. So this method is going to be important. It says keep a face alive. And it says keep vector's face alive using the parameter specified. Called each tick when the face should be kept alive. I don't know yet when this is called, but this is kind of one of those methods that will create the animations for darting the eyes or looking around or making its eyes have some sort of activity when it's probably sitting at rest and sitting in the charger or just sitting and looking around. So here they can put it into a different mode by putting the face into a focus mode, which here they say it reduces the jumpiness and eye darts to make the robot appear more focused and look straight ahead without what they're calling dead eyes, probably without staring and without blinking. So it has some sort of, they tune that animation for that. So remove keep face alive. This probably just stops it so that it won't be doing as much of these. Lets it finish off the blink, and then lets it probably resume the more important animations. Probably animations that are playing, let's say, during a Happy New Year or something. They probably didn't want it blinking during that. They want to have those eyes have all their jittery effects from the animation file there. Some more management here to reset the timers, we said. Keep face the same. Don't know what that is yet used for. So here's a method that they'll call to add a squint. to kind of narrow the eyes but not fully blink them, and another corresponding one to remove it. A method here to add or update eye shifts. So it's interesting what they have here. They kind of have a lot of parameters of when this should occur and how much it should squint and whether it should look down. Then want to remove that. They have something to glitch the eyes, probably to give it more of a emphasize the retro technical feel of where the electronics glitch. So still to emphasize that it's still a machine over the effect. So and then some more helpers. Get max blink spacing time for screen protection. This screen protection comment makes it feel like this is much more intended for Cozmo, where at least according to some documentation, like the patent, they were moving the scan lines around and the blinking and the glitching to reduce heating and on the OLED that would shorten its life. But that may not have actually been necessary the other time, according to some comments we saw in the forum. Then we have the Keep Alive system, which again, this Keep Alive name seems to be a lot around having this eye move around and blink and dart. So Keep Alive consists of multiple modifiers applied to the face when no animation is controlling the face. That seems important to keep the robot looking alive. Okay, that's a good clue as to when this is enabled. So if you probably create an idle animation without a track for the eyes, it just fills this one in. Multiple modifiers exist on separate layers and can be run at the same time. That probably relates to those combination ones that we saw in the animation loader. I don't know why they would do that though at this time. So here's the modifier. Some help using stuff, which is a helper to give names to some more complicated things there. So there's a name for the modifier, the function that is used to do it. It looks like this gets the next time step that it apply at. A Boolean that's something to do with whether or not it has face layers or not, although I would have guessed it did. And then a instance variable for the next time to update it. And then we have down here the instances that actually call each of these individual track managers: the audio layer track manager, the backpack layer track manager, the face, the eyes track manager, and the we have the procedural face, last procedural face. So they probably are using I don't know what they're using this for. And then some keep alive monitors, what we saw here. Be interested to know what's tuning these and setting these to make the face have a particular the blinking and the glancing to match the current internal state of its emotion and stimulation level. Oops, a little typo there. Audio latency offset tracking varies. So valid audio keyframe it. So this probably has something to do with passing the audio keyframes in and sending things like the events or adjustments to parameters. Here they set up more of this keep face alive activity. So there's a method here to begin setting that up and whether or not it has focus. And then methods to apply each of these layers to the actual active animation. So let's go and look at the C++ file now, which digs into this more detail. All right, we have the headers and then include all the C++ header files that define everything, do the namespace setup. All right, so here we have, judging by this is probably keys in a JSON file that tune it. We could find out maybe later that it might be keys for the console var. Interesting. So they use, judging by this, they're either thinking about adding audio glitching, or they stopped using audio glitching. But it looks like someone who wants to experiment with the code eventually, when they can build it, can try turning that on and see what happens. If we're on the Anki Vic OS platform, which is Vector's native platform, it looks like here they set up a variable you can tweak to adjust the audio offset as it takes time to go through all the processes and get to the also Linux sound system and then go out to speaker. So it looks like they probably measured or tweaked this out to be based upon the buffering and other items that it's somewhere around 115 to 200 milliseconds. So 115 probably from ALSA and maybe from the audio kinetic, and then 85 from their buffering. But here's but the console variable lets them tweak and adjust it to see how well the sound works. Otherwise, if this is on some other platform, probably like WebBots, they just skipped over that. So the constructor just sets up the items here, creates the track managers, and I don't know what they're doing by random here for context, but we'll find out eventually. Then initializing it, it clears out the last procedural phase, sets up activities, adds in the callback for the audio. Then they have this update, which I would guess would normally be adding in frames or updating the effects for the animation, but it's completely commented out here. So it says, so it looks like, judging by the comment, Vic Engine could send a message which could enable this face to get distorted and potentially maybe add in some effects around that. It looks like they turned this off. I wonder if this was perhaps a Cosmo thing more than it was Vector, that it would have been made it look more like a glitchy little machine at times. So then yep. So advanced tracks takes a time step and moves each of the 3 tracks to along, a few milliseconds ahead, potentially towards their next keyframe. So, and then apply layers to anim. So they're creating this output animation and go through each of these layers and grabs the next and interpolated, or perhaps just gets the keyframe from that. It's not clear to me whether or not it does the interpolation between keyframes there or not. More importantly, what I want to look at was this keep face alive method. So loop through keep face alive activities and perform if timer expired. Okay, so they have a bunch of modifiers that are looping through them here. And if the next time, they're looking at the next time to do this, and so they're looking at, so there's this is called a regular animation step, and they kind of increment that along until it reaches the next time point where it would run this modifier activity, and then it calls the function to actually carry out some adjustment to the eye animation when it's doing this automatically to create the blinking and darting. So if it did do something activity and it didn't have a problem doing that to adjust it, then it sets this face layer variable. Not be interesting to know why a performance thing wouldn't do something. And then they update the other performance tickers. And then if it had anything, there was any adjustments based upon all the things that can modify the eyes, it calls the keep face alive track, and then it has this parameter here for the layer name. So it looks like that's probably just adding in this procedurally generated eye animation if there's something had occurred at this point in time. So then here, remove keep face alive. So if there's an animation that actually has a face track, they probably just delete. They delete anything here that would be automatically creating stuff. So they remove the stuff for the eye darting and blinking, and these 2 layers here seem to give us a hint here that that's what's going to merge is the eye darting and the blinking. So it probably is moving the eye around, but it can also change the eye height for a blink, so it can blink in the middle of moving. At least, let's go up to the top. We were 138. Yes, there are 3 layers, and now I'm getting it. So there are 3 layers that are merged. So yeah, the eye moving back and forth with the dart, the blinking, which causes the eyes to narrow down, and then some sort of noise. I don't know if the noise is to help get rid of quantization effects so the eyes look better on the LCD, or if they're to add a techno glitch kind of aspect to make the eyes um, have a robotic-y kind of aspect there. So we were 138. Okay, so we removed those layers, or at least two of those layers. Set last procedural face is blank, so they're clearing that out, probably syncing up with some of the other animation tracks. So here's where they would add a squint, some sort of squinting track. I don't know what would cause them to do that yet, but that causes the eyes to narrow and kind of perhaps if vector's looking bored or suspicious, and one to remove the squint. So I wonder if these are called by the Vic engine as part of the behavior tree, or perhaps as a result of the mood engine. So add or update eye shift. So they're going to move the eyes around and make adjustments based upon that. It's a little complicated. Here's where they stop shifting the eyes around. And then here's this add glitch. This restore glitching. So there's some debug information here. Track to generate the face distortion based upon the glitch degree. So it probably causes the eyes to twitch a little bit or to get distortion lines, like the image is breaking up, perhaps. And then if they enabled glitch audio, it generates the audio here to kind of create a sizzle or pop like the old tubes were loose in their sockets. Checks to see if there's any of these three tracks has any frame updates to send to the actual rendering or the audio output. Blink space time for screen print. So this is probably a parameter which is again used to probably protect the OLED display in Cosmo, at least initially, and then they probably just check to see the timing there so that they can add in an animation step to do that. Set up keep face alive activity. So this is a private method that's only called internally, and they got these are probably the procedures that I was calling back later at each of the eye modifiers, because these are these lambdas that are getting set up here. So this adds a blink face to the track, adds blink to audio track. So there must be a ability to add a sound effect for the blinking. I guess I didn't remember that or notice it too much in the past. Maybe it's subtle. So then there's the eye blink time. So it's time for the next one. And I don't know what this in-place back method is, but it looks like they're adding to the blink layer the functions to do it, and then functions to get when to compute the next time to advance that step of the blinking. Similar for the eye darting, they have a lambda function here to add that to the track to move the eyes around, potentially add audio to the eyes, and then some time steps to do that, and then they put that all together for the modifier. And then so down here, it looks like this is probably the last private method for here, where they're adding layers for the audio to the animation. Let's see here, what does the comment say? Due to audio engine playback latency, the animation audio keyframes are not in sync with the rest of the animation tracks while playing. Therefore, we have introduced a variable offset to the latency by playing the audio keyframes earlier, so that they sound better with the animation. Okay, that makes sense. That seems a fairly classic idea. So they go through the keyframes there, and then they kind of look at the list. They get the thing, have audio. Don't know what they're doing here. It's so it says check is it time to play with the audio offset time. Yeah, so here it is. Okay, so the audio. So this is the time within the track, and here's the time within the animation. But they moved ahead a few steps so they can handle. Once they get the audio buffer, they can read it in, decode it, and then move it through this whole audio pipeline so that by the time it gets out, it actually matches up with the display. And since that was 200 milliseconds, that's a 7 frames or so that it could be out of sync with the display. 8 frames maybe. So then it checks to see if there's any layers to send, and sends them. So then finally, yep, there's one for the backpack layer for the same thing. It kind of gets that for the animation for this current time step. So it goes through and gets the same management, but does a similar ceremony. If it has layers to send, it combines them together. Don't know yet what that is. But it just gets the current keyframe for the out frame and sends that out. And then applies that to the rest of the frames. So with these methods, there's some more ceremony than I fully understand what they're doing. And then there's apply face layers. I feel like we've looked at that. This must be the conventional face track as opposed to the procedurally generated one. Makes sense. So they go through and they get it. They have a helper here to get the frames, it looks like, and check to see if it's updated. And then it looks, they say combining it, so I'm wondering if what this is combined with. I got the impression that from looking at the animation, the comments in the animation flat buffer proto, that tracks only, there was a winner which track got selected. One could be disabled, not present. If there was one present, it could be weak, and so that if there was another one there, it took over. And the weak one was only used if there wasn't a better one. But here it looks like they had the ability to combine them. I'm not sure what cases they would use that and how that would impact anything, but they do have that there. So next we'll go and look at the actual frame, the layer manager for the face. Okay, this is the header file for the face layer manager. And the comments here are kind of helpful to understand what the rest of that module is doing. So it's got that keep alive, which is the causing the eyes to look around and to blink. It has look ats while turning, so that the eyes are kind of keeping eye contact as the robot turns around. Potentially, that look ats are also probably used to look at someone's face, based upon what it was getting from the vision system for where it thinks a person is. Blinking the eyes, and then what they're calling repair glitches. So that must be the same glitches we were seeing before. So the rest of the header file is kind of similar structure to the past, got all the usual ceremony. The face layer manager here uses the eye track layer manager interface that's hinted at by the eye, and then it's going to produce procedural face keyframes is what it looks like that they're trying to hint at there. So they have a random number generator. That's what they were being passed in before for the track. So the face helper help to fold the procedural face from the given track, if one is ready to play, into the past procedural. This suggests that perhaps they could glitch a playing animation or modify it in some way. They may have been doing that in the past. I never noticed that. Or perhaps adding noise. So generate eye shift. So generates a single keyframe with the eyes shifted according to the eye shift. So these are generating animation keyframes, and based upon how far the software told it to move, to cause the eyes to move around or look at. So not quite sure what all these values are. So some of these min and max and scales, that kind of is interesting. This perhaps causes the eyes to change shape, get bigger or smaller. You'll have to kind of look into that. Keep alive eye dart, so that's going to be used to do the eye darting. This says all track frames necessary to make the eyes blink, so they have to find it easier to compute all the steps to shrink the eyes and to kind of create that blinking and stretching them out and then putting it back. Oops, typo there. So then it adds a blink face to track, given the layer name. So generate the IDART. So it sets IDART interpolation time. So is focused will cause the eyes darts to be smaller in order to keep the eyes moving but still looking forward. Interesting. So they have different amounts of way they cause those eyes to move around, and some of which is to cause the eyes to kind of look at something but move back. Very clever. All the different thought that they put into how the eyes break the staring and move around, and but still kind of keep with that intent of the mind there. So some alive frames to keep. Don't know what that would be exactly. That just does have the frame thing. Generates a track of all the keyframes necessary to make the eyes squint. So they looks like they do that in a Go. It probably was easier or something. And then all keyframes necessary to make the face have distortion. Okay. Okay, this is the faceLayerManager C++ file that goes with that header file that has all the comment block at the top, all the includes that we would expect. So here's a interesting variable which looks like if that was set to 1, it would enable some extra information to help debug the face layering. We'll have to see what that kind of hints at below. The usual console group names for so that the different control variables can be exposed to that web tool. And then the namespace setup, including making this an anonymous namespace. So these are only available in the module. Let's see here. So these are all the console variables that can be used to tweak and play around with how the eyes do that keep alive thing when it's just kind of when Vector is sitting around kind of perhaps bored and looking. And so let's see here. So it has a bunch of the spacing and how much it can move the eyes. There's a lot of parameters that they have here. So they're using the min-max values that they can have, and then the default value it has there. So that's pretty clever what they did there. So I suppose one could make the robot feel more caffeinated and have jittery, nervous eyes if by tweaking these and making it more aggressive. So here's a medium eye distance dart parameters. When dart's length is larger than threshold. We'll have to see. So they have these medium distance and long distance. And we'll have to see when they trigger using these things. So it says there's this threshold pix here, and this value, that seems to hint that with the comment that it switches using some different values, but I don't fully know. Can't quite intuit here what they would be causing it to do that for. So then some blinking parameters, the time between blinks, the maximum time, so they probably randomize this a bit, which makes sense. So then there's a usual constructor kind of thing. This face helper, which goes through and I don't fully understand what they're doing here. It does seem to have some interpolating of the frames, and the header file did say it looked like it was generating all of the frames for an animation. The header file did have the comment for that. Here's this individual eye shift that it's telling it to do that for, and then it computes a keyframe. And so here's this look at. So in this procedure for proc face, for the procedural face, so this tells it what to look at, but we don't. The look at distance doesn't seem to have anything to do with those other parameters we saw before. So it creates a keyframe there. The get num idart interp frames. So this probably computes the number of frames that are needed for the animation of causing the eyes to dart and interpolate between the major points. Oh, so they're checking here. Interesting thing. So there's this Anki dev cheats. That seems to be enabled in the developer code, so the Oscar builds. So that makes it different than the production builds. I don't know all the time what the dev cheats do, but in this case, they're doing a sanity check to see if this medium threshold value is bigger than the long threshold, because I think, and then it bails out if it is. Um, I think there's other cases where it perhaps does other aspects. You would think that maybe the cheats it led to bypass game steps and for the game developer side of their life, but I don't know all the cases here why they would call it dev cheats for if it was just adding more error checking here for the build settings. As a side note, these build settings, this thing here could have been done as a build time assert that would have stopped the build if these values were out of range. That could be a way to improve the code if anyone's interested, so that you don't even have to have this. And it computes the frames for some number of interpolation frames for the different distances, I guess. So if it's longer, it needs more frames to do that. So here, a dart parameter. So position where the hot spot is on the eye, which I kind of think is probably where the center of the eye is, or its pupil kind of thing. Something called vertical squash to add a sort of mini blink to the dart, so that the so as your eyes are moving, they kind of shrink a little bit as opposed to being a fixed width. It looks like this was, judging by this comment, it was hinted at by the animators. So something that the software folks did come up with their own, but the experts with eye animation did. So interpolate the eye dart parameters. Compute the interpolated position. To produce less linear motion, we move the XY coordinates by differing amounts depending on direction, not in uniform steps. So that kind of probably gives a little bit more of a biological feel, so that it feels more organic rather than feeling more mechanical and perfect. I don't fully know how they're doing that here. They do have these lag fractions that these parameters could be adjusted before, which seems to be causing this arc shape that they refer to. So I bet you, so those parameters in the dart cause it to make it so it doesn't have direct linear movement of the eyes back and forth, and creates a kind of a rounded look. Interpolate the hotspot. So, okay. Hotspot moves in the same direction as the dart vector, but it is simply relative amounts, not absolute positions. Huh. Wonder how I have to look and see how that works out carefully on how the eyes do that. Generate, keep a lot. So the eye dart creator here, and it looks like it. Layer name, time steps. It randomizes some items to figure out where the eyes are going to look to, so that's kind of helps it be organic. So it picks a spot and it moves the eye to and jumps there. Tries to keep it in range and kind of keeps the hot spot of the eye making sense. And then depending upon the number of frames, it looks like, yeah, they just add in the interpolation between the keyframes just by the fact that they know it's going to be 0, 1, or 2. And if there's more than that, then there's just an error message, which will only make sense to the developers, really. Always finish with the final position of full scale. So I guess the eyes move, they kind of stretch and squash, and then when they hit the final position, they go back to normal shape. Then it goes over the eye parameters and does these steps. I don't fully know myself what these eye parameters are doing here. Could use some comments in the code here to help us guess what that is. But they are adjusting, it looks like, the both eyes in a similar way. And then here's the method to create that blink. So it takes a time when it should blink, or what time it is now, and then in that blink process, and then creates each of the frames for the blinking, adding the frame to it. And then so it has that get next blink. So the procedural face drawer, which we haven't looked at yet, looks like that they have something there to draw the blinking differently than they draw the eyes regularly. So this is kind of has a lot of special cases to this animation where they're doing each one as opposed to just tweaking the eye shape parameters. They actually have thought through more of the intermediate steps and have special cases for that. Add blink face to face. Add blink to face track. So okay. Add layer. Yeah. generate the blink. Get the next time for the blink update. Looks like they randomize it a bit for when that next blink is going to occur. Then adds so another one to add the eye dart. Again, it does some checking here, and if no other face layers, it adds the otherwise it's going to, so if there was a active track moving the eyes, it looks like they skip darting the eyes around, so it doesn't interfere with the actual intended animation. So that makes sense. Almost in some ways I wonder why that didn't happen at a higher level than the collar to this instead of this one. I wonder what the thought was, if this was cleaner or not, or if this wound up just kind of being a pragmatic, work better this way. Gets a time for the next eye blink, and that gets another randomized one where they space this out by some range that could be adjusted to I guess change the personality a little bit of the vector. Adds a frac. So, okay, so generate face distortion. What do we get for hints from this? What this face distortion does? It doesn't really say much. It has the same look as all the other one of these things where it generates the tracks, where it just iterates over these things for the number of frames and adds a keyframe in, but not really more than it says. Looks like the face distorter is the scanline distorter. It's not doing anything else there. So I must have thought that was a glitch instead. Yeah, this is just the scanline distorter, but it has the same thing. Generate the squint to narrow those eyes. So let's see here. Does it have anything interesting? So dock squint scale. I wonder if these are what these are. If these kind of doesn't matter the shape of the LCD. So if you had a bigger LCD or a smaller one for like Cozmo versus Vector versus the other robots, if that didn't matter here, or if they would have to change it per hardware. But then they have the time to interpolate between. So it looks like the squinting didn't happen every frame is my guess, because the frames are about every 20, so it's 24 frames per second, and so that would be much faster than this. This is only 4 frames per second. So then all they're doing for squinting is just changing the height of the and width of the eye, and then changing the upper lid angle, the upper eyelid of the eye, and then they're just adding it to the frame to the track. So, anyways, that is kind of covers the main ways they add in all of the moving the eyes around so it looks organic, and then of course links in also some of the the retro technology feel of this of the scanline distorter. And then I guess next time try to dig into how the eyes are drawn.